In today's video, I have brought you a very nice function equation. We get f is defined from R to R, satisfy this following equation. We get f of x plus y over 3 equals f of x plus f of y all over 2. Okay, so our goal, we are going to determine all the functions f, which is verifying this condition. Okay, you can give the try to spam period to solution. Go ahead, pause video when you come back to see the first one. Okay, now let's jump into solution. First of all, as we go with the solution for this kind of these functions, always we are going to give some values of y or x in order to reduce the equation to the smallest expression possible. Okay, the first convenient value which is going to work with this equation, I'm going to take y equals 2x. Why? Because I see here, if I'm going to add 2x here, I get 3x over 3. I will get 3 cancelled out. I will be left with f of x. Okay, so let's do that. So let's set y equals 2x first. So this one is going to give us f of 2x plus x, which is 3x over 3, which is x, f of x. This one is going to give us f of x plus f of 2x all over 2. Okay, it's more clear. So then, crossing the multiplications, I get 2f of x equals f of x plus f of 2x. So I get 2 of f of x, which equals f of x plus f of 2x. It's more clear here. We get f of x, we get twice f of x. I'm going to cancel one of the f of x from both sides. I will be left with this following equation: f of x, which equals f of 2x. So I'm going to box this one. Let's name the equation this one. Let's name this statement as the equation number 1. Now let's move on to choose another substitution. Okay, so another appropriate substitution which is going to be working with this one. Let's set y equals minus 4x. Why I'm choosing this one? Because if I'm going to replace y with minus 4x, I get minus 4x plus x, which is minus 3x. It will be cancelled out with this 3. I will be left with f of minus x, which is good. Okay, so this one is going to give us x minus 4x, which is minus 3x, is divided by 3, which is minus x. So I get f of minus x is going to give us f of x plus f of minus 4x all over 2. After simplification, it's more clear. It's going to give us 2 times f of minus x, which equals f of x plus f of minus 4x. It's more clear. Okay, so I'm going to box this one as well. Let's name this one as equation number 2. Okay, if you take a look at the first and the second equation, we have f of x in both statements, but if I'm going to cancel this one, f of x is not going to take me to anywhere, because I will have another unknown variables. I get f of minus x as well as f of minus 4x, which is no good. Okay, so what to do in order to get rid of this f of minus 4x, I leave only f of minus x and f of x involving in this equation. Okay, so if you take a look carefully here, we have a kind of relationship between the first and the second term. Also by induction is going to give us f of x, which equals f of 4x. Okay, because I get f of x equals f of 2x is the same as f of 4x is the same as f of 2 to 3x and all the way down to the f to the nx. Okay, so now I'm going to put the substitution minus x instead x here by replacing both of the term of the equation by minus x, which is going to give us f of minus x, which equals f of minus 4x. Okay, it's more clear. So we have this a nice relationship between. What to do now? I'm going to replace f of minus 4x with f of minus x in the second equation. So I get the following: I get 2 times f of minus x, which equals f of x plus f of minus x. Now it's more simple. So I get twice f of minus x on the left hand side of this equation. Also get f of minus x on the right hand side of this equation. So I'm going to cancel out that. So I get f of minus x, which equals f of x. It's more simple. So we get f of minus x, which equals f of x, which means f is odd. Okay? Even or odd is not going to help us here, but just we notice it. Okay? What to do now? I'm going to put a third substitution. I'm going to put y equals minus x. Let's set y equals minus x. Why I'm going to do that? Because if I'm putting minus x into y, I get f of 0 here, because the numerator will be 0. Okay? Then on the right hand side of this equation, I get f of minus x by replacing y with minus x, which we have here. We can replace it as a substitution as well. Okay? So what to do? I will have f of 0, because y minus x plus x, which equals f of x plus f of minus x all over 2. Then crossing the multiplication, I get 2 f of 0, which equals f of x plus f of minus x. Okay? This f of minus x is going to be replaced with f of x, which means I get 2 times f of x. Okay? Because this one is f of x. Then I get 2 times f of 0 equals to f of x. I'm going to cancel out number 2 from both sides. What I have ended with, f of 0, which equals f of x, which is a constant. Thus, I have f of x, which equals lambda, with lambda is a real number as a constant. Okay? Let's get rid of this one and move on to the second method. The second method is going to be quicker. In the second method, let's set y equals x. I'm going to replace y with x here, so I get the following. I get f of x plus x, which is 2x over 3, which equals f of x plus f of x all over 2, which equals f of x. Okay? So we get f of x, which equals f of 2 over 3x. Since we get f of x equals f of 2 over 3x, the second one is going to be 2 square over 3 square x. The third one is going to be 2 over 3 cubed x, and all the way down to the f of 2 over 3 to the n x by induction. Okay? Then what to do now? I'm going to apply the limit on both sides. So we get the limit of f of x. Since we have f is a continuous function, this function is definitely a continuous function. Since the function is a continuous function, we are going to apply the limit on both sides. Okay? So if the function is not continuous function, we cannot apply the limit on both sides. Okay? So f is a continuous. So the limit as n goes towards infinity. Since the limit n is dependent on n, so this one is going to be f of x. So equals the limit of f of 2 over 3 to the n is multiplied by x as n goes towards infinity. Since this one n is going towards infinity, this one is going to be 0. So which equals f of 0, which is a constant. We see as a real number. Okay? So I have ended this video. Thank you for watching. We will see you next video. Bye.